Good afternoon. Right now we're going to go over three different types of questions. One is through graphing. We're going to solve system of equations by substitution, and we're going to solve systems of equations by the addition or elimination method. It's called both interchangeably. So the first one here, they're asking is negative 4, 5 a solution? Is this point right here a solution? Well, what they're implying here is that you solve it by graphing, and then you find out if the solution that you get by graphing is the same as negative 4, 5. I know there are other ways to do this, but this is, in particular, this is a graphing. They want you to show that you can graph it. So what's our first step? Does anybody know what we do first to graph this? Yes, Brian?
Wait, to graph it, couldn't plug it in first?
To graph it, well, to get the graph. How do you make these two
So
equations?
plug in negative 4.
No, that's another method. We're not doing that here. How do you graph this, Tamara?
You get y equals mx plus 4.
That's right. How do you do that?
You subtract the x and the y, which equals
You,
y.
well, you don't subtract the x and the y, you just subtract the x, right?
Yeah.
So y equals what?
Y equals negative x plus 1.
Good. So far so good, right? Because now we can graph that. How about this one here? I'm going to create a little more space here. 2x plus y equals 3. Okay, how about this one? How do we convert that one? Sophia, what do we do? Subtract 2x on both sides. And what do we get? Y equals negative 2x plus 3. So Shannon, what's our what do you call it? What's our slope there? And our y-intercept?
Oh, m is 1.
Pardon me?
Would it be 1?
Okay.
Negative 1.
Negative 1. And what's our b? What's our y-intercept? 1. You don't have to frame on me, right? You're just getting the board? Okay, so what about this one? What's our slope and y-intercept there? Taylor? Not sure? Remember y equals mx plus b?
Your slope is out.
Oh, really? Okay. Y equals mx plus b. Notice how I write the m and the b right underneath, lining up with the x? So Amanda, what's our m and what's our b?
Your m is negative 2 and
Right.
your b is 3.
See that, Taylor? If you write it right underneath, you see how they line up? Kind of. So m equals negative 2, and b equals 3. Now, why did we bother getting all that information? Well, because with this information here and that information there, we can graph it. So what do we need for graphing? Put your feet down, Michael. Okay, and Sarah, what do we need to graph that? What do we use here? We use the rise over run, but we don't have any idea where we are on the graph, right? Rise over run just tells you the slant of the line, but we can't even start unless we know where we are. You know what I mean?
Don't you start with negative 4 and 5?
But from where?
Negative 4 and 5.
From where? From the y-intercept, right. So you have the right idea, I know you know how to do it, but you have to say it right. You have to get the y-intercept first. You have to plot the y-intercept before you start doing it. Stephen, can you sit properly over there? Thanks. So down here, you're right, Sarah, you go down 1 over 1, and you have your first line, okay? And you always label it. X plus y equals 1, all right? That's your first line. Now this one right here, what do we do first, Natalia? Y-intercept is 3, right? Okay, so we've got 1, 2, 3. Okay, and then what do we do after that? Stephen? Okay, we've got our y-intercept, and we need to use our slope? Right, good.
Put your y-intercept.
Yep. And then where do we go?
Down 2.
Over.
1.
Good stuff. Back on. Thank you.
Where they intersect?
It's where they intersect, that's right. So where do they intersect?
Right there.
Right there, right, good. But where is that point?
Right there.
I know, but where is it approximately?
It's like down
5, right?
Yeah.
5, negative
down 4 over 4.
Pepper? Yeah, down.
5, negative 5.
Okay, something like that. We go down, let's say 5, and over 4, about 4. So that point is approximately down 5 over 4. So this point, to finalize this right here, this point here is the solution. Is that the same as what they're suggesting the solution might be?
No.
No, not at all. So what's your answer? Is negative 4, 5 a solution?
No.
No. So big no.
I was right.
You were right. But you have to show why you're right. You can't just put no. Number 10, solving by substitution. It's different than graphing. You're not creating a graph here. All you're doing is taking one equation and substitute it into the other. But how are you going to take one equation and substitute it into the other unless you've identified one variable that you can substitute for the other? So our first step is what? Yes?
You need to take away y from x.
Yes, good. You can isolate either variable, but in this case it really doesn't matter which one. I wouldn't do 4y because then you'd have to deal with a fraction. I wouldn't subtract x in there because then you'd have 4y equals negative x plus 3. You'd have to divide by 4, you'd get a fraction. And you could do it, but it'd get more complicated. This is the easiest way to go. You could have done negative x and then solve for y, but either way, you've got a simpler equation on the first or the top one because they don't have coefficients. They don't have numbers in front of them. So from there we get what, Shannon?
X equals negative y plus 6.
You got it. Good stuff. Now what do we do with that? We've set ourselves in the right position, but where do we plug it in?
So that x is the second term.
Right. So let's just put a pocket. Now you guys remember the pocket system that we initiated way back in September?
Oh, yeah.
And it was easy then, and you were thinking, well, why is he doing this stupid pocket thing? I mean, you know, it was so silly. Well, as you're getting more complex questions, hopefully you're seeing the value of this thing. We leave the space blank, and we fill it in with something that is the same as x, but is in terms of y. So, what do we put in there?
Negative y plus 6.
Negative y plus 6. We solve for x to isolate it so that we can substitute it into there. Now the next step. Well, what, do you know how to do these ones? You know what to do on this one? Try to bring you in the loop here. You see what we did with the substitution?
Yeah, I did that.
You did that? Okay, now what do we do here?
The next step.
Next step is what?
You know it?
What's that?
Oh.
Siobhan? Okay, that's fine. Brian?
I don't know.
Jonathan?
Combine like that.
Combine like terms. Sophia? What do you get? Okay. 3y plus 6 equals 3. You see that more?
Yeah, I did that.
Good.
Now you subtract 6, right?
Are you being difficult now? Are you pouting? So 3y equals negative 3. Are we done? Not quite. We're almost there. Tamara, what did you do to finish this? We got the y coordinate of our point of intersection. We need to get the x coordinate. How do we get it?
Oh,
You know, Shannon?
yeah, you have to plug that back into x plus y equals 6.
Yeah, or there, or there. Doesn't matter where, right? I prefer to put it back into here because you've already made it. You've already made it look, you know, easy. X equals negative y plus 6. So why not put that back into here? I'm going to actually rewrite it. X equals negative y plus 6. And I'm going to go ahead and create a pocket around the negative y. And then we're just going to put this whole thing right in there, okay? And we get x equals, in fact, I'll just make that a negative 1.
So
And x equals
7.
1 plus 6, x equals 7. Now the final step, what's the final step?
Oh,
What?
You put it, put 7, and that's negative 1.
7 and negative 1.
It's just positive, so it's...
Yeah,
wait, where'd you, oh, I did it.
7 and negative 1, okay? Okay?